Hello and welcome to this video. This video takes off kind of from where the last video stopped, except that what I have done is I've taken this last expression that we had and I have just written the next equation after it so I don't write this long expression during the video. Okay, so what we have, we basically just expanded this right hand side, took this left hand side to the right hand side and put it on top of the same denominator. So, having come up with that, some terms cancel out and you're left with, if you want, let me write this so that I don't have to write this brackets over here. Let me write this simply as your transfer function, which is x1 over s divided by f of s. Okay, so if we're doing x1 over s divided by f of s, that is simply, let's see, can I get this to show a little better? Give myself more space to work with. That will just flip this on its head. So this will now be equal to, and as the numerator, I will have s d3 plus k2. All of this divided by, now can I attempt to collect like terms? It will help a lot if I can collect like terms. So I have s to power 4 m1 m2. Let's have that here. S to power 4 m1 m2. So to make my life easy, what I'll try to do is to cross out ones that I have used. So I've used that. Let me mark that out. Now I want the s cubed terms plus s cubed into, I have one term here, d1 m2, d1 m2. I have d3 m2 plus d3 m2. I have d2 m1 plus d2 m1 plus d3 m1, d3 m1. Any other third order term here? There does not seem to be any, so I have four terms to cross out. That's 1, 2, 3, and 4. Okay, let's pick the s squared terms plus s squared into, first term to deal with is this one here, m2k1 plus m2k2 plus d1 d2 plus d2 d3 plus d1 d3 plus m1 k2, and I think that's the last one. So that's 6 terms to cross out here. Let's see, that's 1, 2, the third one, 3, 4, 5, and 6. And we're left with 2 sets of terms. The s terms plus s into, so how far have we gone? We've come to this point, d2k1, d2k1 plus d2k2 plus d3k1 plus k2d1, and I think that's what we have for the s terms. So that's 1, 2, 3, and 4, and we have just one term left plus k1, k2. And this is our denominator over here. So maybe I should just put this in square brackets so that we can see that. So this is our denominator. It's a fourth order system. So this is a fourth order system from what we can see over here. So a rather simple looking system with a rather long long transfer function. However, it's not difficult to come up with this. Yes, I know it's a little tedious to just write and make sure one doesn't make any mistakes, but then this is a solution we come up with. Now, we could have asked the question, what would have happened if my x2, so this was what we were working with. Let's say instead we were told that our x2, if we were told to find our x2 of s, over f of s. In other words, let's assume that x2 was the transfer function. If that was the case, then instead of using the expression, instead of using this expression, would have used the expression on its head. In other words, wherever we had x1, would have used slot in this expression. So we could have slotted in this expression over there and would have come up with a solution that would also maybe arguably will also be relatively long, but then we could have come up with that solution. So just to mention that we chose that x1 was specified as being the output. Well, that's our output, so we found that transfer function. We could have found the transfer function if x2 were the output instead. Okay, so I think I'll stop this video at this point and we'll continue in the next video. Thank you.